So section 1.2, we're on Roman numeral 2. We've been working with expressions, and now we're working with equations. So what is an equation? A mathematical equation or an algebraic equation? It's got an equal sign, right? Pretty easy to spot. So really what it is, it's a sentence. You can read it from left to right, and the verb is the equal sign. It means what? Is, and it equates to mathematical expressions. Now there are several different type of equations, so let's just quickly go through them, and then we're going to end with what's called a conditional equation, and that's the ones we're interested in today. But while we're talking about equations, let's kind of go through the gamut here. The first one that I call, for lack of a better name, is just the name equation. And all the name equation is it assigns a convenient name to an expression. So you don't have to keep referring to it as, hey, you, or 2x plus 4, right? So in this case, in algebra 1, you had the line 2x plus 4, and you called it y. It could be the name. And then you stepped it up a little bit and started using function notation, bless you, and you replaced y with f of x. So this is the name of this expression. The name is actually f, and the independent variable is x. So you have g, f, h. Those are typically the function names that we give, but you can really pick anything. So what do we do with the name equation? We don't solve it. We just refer to it. Okay, so if you wanted to refer to this giant expression 2 sine blob plus 5, just give it a name, call it f or f of x, and now you can refer to it as f. The next type you've seen, it's called a contradiction. And when you were finding a counterexample on the previous worksheet, on the last problem, remember? You were trying to find some values that did not work. That's what a contradiction is. It's certainly an equation. It has an equal sign, but it's never true. Okay? It is never true. For instance, 0 equals 1. True or false? False. That's a contradiction. Here's one that's interesting. 4 equals 4. Is that true? Say it with enthusiasm and without enthusiasm. Is it the same? This exclamation point in math doesn't necessarily have anything to do with enthusiasm or what you would yell on a golf course when you hit an errant shot. This is called factorial. And factorial is a way to quickly express the product of an integer times all of the positive integers that precede it down to 1. So for instance, 4 factorial, we call it, is equal to 4 times 3 times 2 times 1. And it's useful when you talk about like probabilities or counting things, right? Like if you have 4 people, how many different ways can you arrange 4 people side by side? Well, there are 4 ways to pick the first person. Then there are 3 ways to choose the second person, 2 ways to choose the third, and one way to choose the last. So there would be 24 combinations of 4 people. That's the idea behind it. So 4 does not equal 4. Contradiction. Now those are just numbers. Here's a contradiction that actually has variables in it. Okay, and what's the consequence of that? For how many values of x would that equation be true? None. Very good. So if you were to graph this, and we'll study this type of function later in the year, and you were to graph that, how many times would these 2 graphs intersect? 0, right? Because the points of intersection end up being the solutions. So these 2 graphs would not intersect. So you have contradictions. You don't solve them, they're just never true. All right, the opposite, if you want to think about it, that to a contradiction is an identity. And we're going to be studying a lot of trigonometric identities later in the year. An identity is an equation that is always true. Always true. For instance, 0 equals 1. Now that's kind of weird, because notice 0 doesn't equal 1, but if you put enough oomph behind it, it would appear that they are. Kind of funny, right? 0 factorial is equal to 1 factorial, okay? And it has to do with the recursive definition of factorial. So if you type it into your calculator, you see that they both equal 1. Kind of interesting. Here is an important one. Sine squared of x, that's how we read that, plus cosine squared of x is always equal to 1. They are mathematical synonyms. They are interchangeable. So if you're ever dealing with the number 1 and it's too awkward and cumbersome, you can just replace it with sine squared plus cosine squared, and everyone will know exactly what you're talking about. Okay? And this is a very, very important identity. The absolute value of x is equivalent to the square root of x squared, in that order, because they both accomplish the same thing, but by a slightly different means. What does the absolute value of x do? It takes away negative if it's there. So how do you apply it? Well, if it's positive, you just take it as is. If it's negative, you just break off the negative and throw it away, right? That's how that one does it. But the square root of x squared does it a little bit differently. It takes any number and squares it, which makes it positive but also makes it bigger, and then it chops it right back down to size by taking the square root of it. They're identities. Why would you want to have this as a mathematical synonym? Well, it's easier to work with what ponents? Exponents. And we have exponents here, than it is to work with absolute values because you have to break it down into a piecewise function. So we'll be dealing with that on and off. Now, the last type of equation are the ones we're interested in. They're called conditional equations. And as the name implies, they are equations that are only true in certain conditions or for certain values of x. And so what do we do with conditional equations? We seek out the optimal conditions, or we solve. We solve. Okay? We solve. So let's go ahead and read. To solve a conditional equation systematically, some of these are going to be so easy, you're going to be able to look at it and say, I know what the answer is. That's great. Well done. But the power of algebra is coming up with a systematic process or an algorithm for solving things. Okay? So if you only have a single variable to the same power, like in part 2a, you will just have a z, and in part 2b, you just have a y squared. What you want to do is get your variables on one side and your numbers on the other. Okay? Separate the variables if you only have one variable of a particular type. So go ahead and set out and solve number 2. This is algebra 1. When you're done with A, jump over to B and do some algebra 2. Solve for y. So I'll let you do those on your own. Solve for z and solve for y. And while you're doing that, I'm going to be doing it too. And if you're watching at home, this is your chance to do it as well. I'm walking around and I'm seeing some people get the same thing I'm getting, which makes me feel pretty good. Because I wasn't sure if I was doing it right. All right, most of y'all are done with A. Let's take a look at it. I think Z is 8/19. You get negative 8, negative 19, which of course you simplify to 8/19. You have one variable here, Z, and it's all to the first power. So what you're going to do then is try to get Z by itself on one side and numbers on the other. So you separate. It's a little bit different strategy than what we're going to do here in a second. You actually physically separate. So to do that, you're going to have to untrap the Z's that are inside these parentheses by expanding it out. So you got to be very careful. Some people forget this -5, and they forget the sign on the 3. It becomes -15. With the notability, you have the ability to kind of color code things. So maybe use it to your advantage. If not, if it's a pencil, underline it or circle it. But I got all my Z's on the left. Typically, I put variables on the left. So when you bring Z across, it becomes negative. And then the two numbers that I put in purple nurple came to the other side, and they changed signs. And I actually showed all of them before I combined them. Then carefully combining them, divide through, you get 8/19. Now, this would be, of course, the correct answer. What do you anticipate, being students of math, if this were like answer choice A, that would be the one hopefully you'd choose, what do you suspect I might put as another answer choice? Negative 8/19 for sure. Yep. What else do you think might be an answer choice? 19/8. Exactly. And of course, then maybe negative 19/8. Why 19/8? I'm guilty of this myself. You get down to this last line right here, and you see the finish line, and you kind of relinquish your brain from the problem, and you start thinking about other things, like maybe lunch, or maybe the next problem, and you just let your hand finish up the job. And you carelessly divide by the wrong one, right? You know you have to divide by something, but you carelessly divide by 8 instead of the 19. So it's real easy to do. So I would always say run through the tape at the end of the race, right? You're running a marathon, you run the first 26 miles, you might as well run the last 300 yards, right? Run through the tape. Finish strong. So the answer is A. Very good. Now over here on B, it's very similar. We just have a single variable term of y squared. There's no y squared and a y term, just a y squared term. So in this case, same idea. We want to isolate the variable on one side, get the numbers on the other. So we're separating. And to do that, we distribute. So let's go through this one a little bit more quickly. We get 8y squared minus 24 plus 8y squared minus 24 equals 16. And boy, those look, wow, that looks the same, doesn't it? In fact, I think there could have been another way to do this, but this definitely will work. Like terms, I'm going to collect my variables on the left. So I got 8 of them plus 8 of them. That's a total of 16 of them. And then I'm going to have a minus 24 minus 24, which is a minus 48. And I got a 16 over there. Now, you could have brought the 48 over there on that line, but why rush it, right? Bring it to the other side. It becomes positive. Now, here's another case where you can kind of be hasty, and you bring the 48 across and you don't change its sign. So it becomes a positive 48 plus 16, which is 64. And then you divide both sides by 16, and you don't have to show the division line. 64 divided by 16 is 4. 4, and then here's where you want to run through the tape. To solve for y now, you have to do what's called extracting the square root. So you take the square root of both sides. The square root of y squared is y. And, of course, you get the square root of 4 over here, which is 2. But let's back up a second. In Algebra 1, your variables were to the first power. That's what made them linear. And you had, for linear equations, at most, how many solutions? 1. Good. In Algebra 2, or late Algebra 1, you had variables that were raised to the second power. Those were quadratics. They had, at most, how many solutions? 2, because you're looking at x-intercepts. Lines can cross the x-axis once. Parabolas could actually cross it twice. Now, they don't have to have 2, but you want to be looking for 2. So I got y equals 2. That's one solution. Where would the second one possibly come from? Negative 2. Yeah, and this is a very common thing for students to forget. When you extract an even root, whether it's a square root or fourth root or sixth root, you must consider plus or minus on the numeric side. If you're the one introducing the radical, you have to consider plus or minus. And that's the difference between getting the answer right or wrong, you know. So plus or minus 2. If you're taking the cube root or the fifth root, you don't have to do plus or minus. And the reason is, if it's an even root, then you have pairs of numbers. And a negative times a negative is positive. Okay, so that's why you consider it. So plus or minus 2, you have 2 solutions. Don't forget to extract both roots. All right, so any questions on A and B? You had one variable representative. You separate. Numbers on one side, variables on the other. So what happens if you have fractions? Like example 3. Y'all like fractions? Already this year, you are better with fractions than you were just a week ago, right? We've worked with them quite a bit. So if you ever have a linear equation like this, and what makes this one linear, by the way? There's no squares, right? It's just t to the first, t to the first. So it's a linear equation. So it's going to have at most one solution. There are 2 ways to work a problem like this. and we're going to do it both ways. The first way is to embrace the fractions and work with them, and the second way is to get rid of them. So if you are not good with fractions, which one should you do? Maybe when it's crunch time, you do the second one, but when you're practicing, you do the first one, right? Patton says man must travel in the direction of his fear. That's how you grow. So if you're not good with fractions, you might want to work with fractions, develop your weakness. But then when it comes crunch time, maybe you do this one here. We're going to go ahead and embrace the fractions first, because I know how much y'all are starting to love fractions, right? It's an acquired taste, like coffee, and then you get hooked, right? Got to have my fractions. Okay, so step one, if we're going to embrace the fractions, we got to get the t's by themselves, which means we have two terms up here. Here's a little trick that we'll be using quite a bit. You can split up numerators. So you can call that t over 3 minus 1 over 3. You can't split up denominators that way, but you can split up numerators. So you got t over 3 minus 1 over 3. It's like getting a common denominator and adding them together, but you're just breaking it apart. Similarly, you get t over 4 plus 5 over 4, and it equals a half. Now, by doing that, we can now isolate the terms that have the variables in it. So let's get out our little highlighter, and I'll highlight the variables in pink, and the other ones won't be highlighted. So let's go ahead and combine those now. T thirds plus t fourths. That's the same as 1/3 t plus 1/4 t. And let me write that out here because that's kind of news to some people. If you have t over 3, that's the same thing as 1/3 times t off to the side. In other words, you can kick a factor out of the numerator and think of it now as a fractional coefficient times t. So these are like terms. So basically, what is 1/3 plus 1/4? You can do your crisscross applesauce. Good. 7/12. If you need to do it off to the side, 4 plus 3 is 7 over 12. So you're going to get 7/12, and I'm going to go ahead and put the t off to the side. Or you can put 7t over 12. It just looks a little bit nicer like this. Now, since we have the ability to combine these on this side before we take it across, let's do that. What is 5/4 minus 1/3? Well, off to the side if you need to. 5/4 minus 1/3, crisscross applesauce. 15 minus 4 is 11/12. And that still equals a half. Fun with fractions. Okay, so now we'll combine like terms. I get 7/12 t equals, when I bring the 11/12 across, it's going to be 1/2 minus 11/12. 1/2 is how many 12ths? 6. So what is 6 minus 11? Negative 5/12. Right? Now, this problem, where we're at right now, this is 8th grade algebra. My daughter was doing problems like this last night. How do we solve for t? Multiply both sides by the reciprocal. Yeah, we had that conversation. Now, her math teacher is Mr. Bryant, Coach Bryant's wife, and she said that the kids had to say it a certain way, and I loved her for it. See if you know, because I've emphasized it this year. What happens to the 12/7 and the 7/12 over here when we go? They divide out. Very good. They don't cancel. They divide out. And Mrs. Bryant said, they divide out, they don't cancel. And I'm like, yes, thank you. And we get 1. Things divide out to give you 1. And over here, don't multiply straight across. What happens to the 12s? They divide out, and we're left with negative 5/7. And that's our answer. If you weren't sure, you could plug it in and check. But I'm kind of feeling like we're awesome, and we didn't mess up. So you can go with it. Now that's embracing the fractions. Wasn't that fun? If you tell yourself yes enough times, maybe you'll start to believe it. Okay? The power of positive thinking. Now there is another way to do it. Okay? And when push comes to shove, maybe you do it this way. Clearing out the fractions. To clear out the fractions, you're going to have to multiply both sides by a number that when you distribute will divide out with each of these, which means we are looking for the what of 3, 4, and 2? The smallest multiple that they go into. So the LCM. What is the LCM of 3, 4, and 2? 12. Now, any CM will work, but the least one is going to be ideal. So parentheses are on both sides. We got a 12 over there, got a 12 over there. If you want to put it over 1, feel free. So here's why it works. When you distribute now, do not go 12t minus 12. Don't distribute it to the top. That defeats the whole purpose of what we're doing. Divide before you multiply, right? Go small before you go big. What's 12 divided by 3? 4. So 12 thirds gives you a 4, and then that's going to be times t minus 1. Plus, you distribute to the next one. What happens with your 12 divided by 4? You get a 3. So plus 3 times t plus 5. And then over here, this one's easier. 12 times a half is 6. And now you're kind of in your happy place, right? Because there are no fractions. It's almost like we're back up here on example 2a. So if we just distribute 4t minus 4 plus 3t plus 15, we're like not even breaking a mental sweat here. No fractions. Not nearly as fun. Combining like terms, I got a 4t plus a 3t. That's called a 7t. And then on the left side, I got a 15 minus 4. That's an 11. When I bring the 11 across, it becomes negative 11. Plus 6 is negative 5. And we're rounding third, heading home. The ball's in the outfield. We're going to score. Negative 5 sevenths. Got the same answer. Which way was correct? Both. Both. Which way was more fun? Don't answer. That's an opinion. The answer is A. It was more fun. Yeah. Okay, so you have the option. You have the option. Okay, so let's look at this important idea. This is called the zero product property, and it is heavily dependent upon, guess which number? 0. Okay, here's what the zero product property says. You've seen it before. If the product of two or more things, in this case A times B, equals 0 and only 0, then we know for sure that either A equals 0 or B equals 0, or possibly both. But at least one of them has to be 0. In other words, there's no way to get a product of 0 unless you have a 0 factor. No way, no how. Okay, so it only works for 0. Like if you had A times B equaling 5, does that mean that A has to equal 5 or B has to equal 5? No, it could be that neither one of them is 5. For instance, what? What are two values that when you multiply give you 5 where neither one of them is 5? 2.5 and 2, right? 25 and a fifth. There's lots. Neither one of those are 5. But if it's 0, one of them's got to be 0. So why is that useful? Well, it's useful because if we're trying to solve an equation and we can, what? A times B, A and B are called what? Factors. If we can factor it, then I can break down a problem from like a quadratic into linears. I can set them each equal to 0 and solve a linear equation. Okay, so let's read these things in bold, in all caps. The first rule of factoring is to what? Look for a common factor, right? Duh, we know that now. This is not another rule, but it is pretty important. It says never, never, never. How often is that? That's never. Never divide out a variable from both sides of a conditional equation. Because if you lose it from the equation, you're losing information, which means you're losing possible what? Solutions. Okay? And that's not good. Now, sometimes you can like divide it out on one side, and it might appear on the other side, and you're like, oh, look at that trick. You can went over here and came out over here. If he still stays in the equation, it's okay. But if he goes away from the equation, not okay. All right, example 4. How much time do we have? We have plenty of time. Quit worrying. Okay. Let's try example 4. We're not going to do all these, so let's try which one looks more scrumptious. Good. Let's try B. Let's try B. Now notice, in this case, we are not trying to get x's on one side and numbers on the other. Why? We're still trying to solve for x, but here I have a squared term and a non-squared term. So I have two different types of variables. If this had not been here, if it were just 2x squared equals 48, now you can separate and extract square roots. But if you have more than one type of variable term, you don't want to separate. You want to set it equal to 0. Okay? So that would be your first task. 2x squared plus 10x. And how do I get it equal to 0? Do I divide both sides by 48? Subtract. Yeah, that would set it equal to 1. Okay, so now we have a quadratic trinomial. X squared, x 48. The zero product property says if I could factor this expression, I could set each factor equal to 0. So now it's a problem like what we've been doing, right? First rule of factoring is to what? Find a common factor. Does we got one? We got 2. So we're not going to get rid of the 2. We're just going to pull it out front. We want to keep everything intact. Now, technically, you could divide both sides by 2 because 2 is a number and 0 divided by 2 is 0. But you don't want to lose any part of the function. So let's just leave the 2 out front. We get x squared plus 5x minus 24. Now, here's the other important part. Some people, because we're working on the meat of the problem, which is factoring the expression, they tend to lose the equals 0 all the way down the right-hand side. Do not do that. If you have to come back at the end and just add them, go for it. Because if you leave it off, you're going to lose a point. We don't want to do that, okay? We're solving an equation now. Okay, so now it's the easy variety. Factors of negative 24 that add up to 5. Yeah, an 8 and a 3, and it's got to be a positive 8 and a negative 3. There you go. Now, here's where the zero product property comes in. I have 3 factors there. The zero product property says any one of them might be 0, but for sure one of them is. So let's go ahead and do that. The zero product property says either 2 equals 0, or x plus 8 equals 0, or x minus 3 equals 0. And what we do now is we solve all of those. Well, here's where some students get confused. For what value of x is 2 equal to 0? You can laugh, right? Is 2 equal to 0? No. So this is not going to give us the solution. Some students, when they see a 2 out there, they say x equals 2. I don't know why. Okay? 2 is never going to equal 0. Will x plus 8 equal 0? Yep, when x is negative 8. Will x minus 3 equal 0? Sure, when x equals 3. So here are your 2 possible solutions. Now, truth be told, you do not have to actually show me the zero product property in action if you get it into its complete factorization. Because if you know the factor, x plus 8, then the associated root is negative 8. And if you know the factor of x minus 3, then the associated root is 3. A root means when you plug it in, you get what? 0. So that's very important. So if you want to go straight from the factor to the answer, that's good. Okay. Letter C. Let's try letter C. You try letter C, I'll try letter C, and we'll compare answers, okay? Letter C. Ooh. Letter C. You get what I got? You got what I got? It's the same. Nice. Try it out. Try it out, see if it works. Right? You can always get in that habit of testing out your answers. I don't know what I'm doing. Anyone get 10 or 9? I walked up to the problem and I know I had it factored in. And I was like, it's already factored. Look at that. So x plus 2 equals 12 or x plus 3 equals 12? X equals 10 or x equals 9? Piece of cake. You better be careful because when you solve an equation, you are declaring to the world that this is a solution to this equation. And you don't want to walk around with egg on your face all day, do you? Gross. Embarrassing. So what can you do before you make the declarative statement that x equals 10 and 9? Check. Right? You're saying when you plug in the 10 up here for x, you're going to get a 12. Let's try it out. 10 plus 2. 12, okay? Remember that. 10 plus 3. 13. Is 12 times 13 12? No. So guess what? That's wrong. Sometimes you can't take back your mistakes. Here I can. All right. So why is that wrong? The zero product property only works with what number? 0. Is 12 equal to 0? Nope. So will I bait you into doing something like that? Yep. So this is really an expanded x squared, and you're going to have an x term. So you get everything on one side and set it equal to 0. So when you bring the 12 across, it's going to become negative. Now it's equal to 0. You might as well go ahead and expand the binomials that are multiplied. Now, I don't like to use FOIL here, so I'm just going to distribute. It's a lot better. X times x is x squared, plus 3 times x is 3x. Plus, move on to the next one, 2x plus 6. And once you do all that, you can combine like terms. You got an x squared plus 5x, and then minus 6. Now it's equal to 0. And now that it's equal to 0, now you can try to factor it. It's going to be one of those ones, if it works, that has an x and an x, because the leading coefficient is 1. So please, oh please, let there be factors of negative 6 that add up to positive 5. 6, 1, positive, negative. Yeah. Now the old 6-5 combo is the one that sometimes gives students some fits, because a 3-2 combination also might work. 3 times 2 is 6, and 3 plus 2 is 5. So you have to make sure you're looking at the sign. So what should you do quickly before you go any further? Check, right? You're going to get a positive 6x on the inside, minus x on the outside. 6 minus 1 is 5, and that's good. And then you have a negative 6. So check your work. And now the zero product property says each of those equals 0, but you don't have to show it. You can go straight to x equals what? Negative 6 and positive 1. Now, I learned my lesson, so before I walk away, I'm going to try out at least one of them. Let's try out the 1. It's easier. 1 plus 2, 3. 1 plus 3, 4. 3 times 4, 12. Ha ha ha. That's good. That's good stuff. Now, what if you got down to here and it didn't factor? Would you be able to solve? Is there a way to solve a quadratic if you can't factor it? You can complete the square, maybe, or the quadratic formula, right? And everyone knows the quadratic formula, right? And if you did forget the quadratic formula, all you have to do is reference your tattoo, right? Okay, good. So hopefully it factors, right? We don't have to show our tattoo. All right, letter D, you go. I'm going to go, you go. We'll compare answers, okay? I go, you go. We all go. Here you go. Doesn't work. Okay. Ice cream. That's what. Ice cream. Ice cream. They're going to bring ice cream trucks back in the Rockville. Did you hear that? City Council passed the ice cream truck rule. So you can have ice cream trucks going through neighborhoods now with the music playing. So be careful. When you bring everything across, it's an equation. So where'd your equation go? There you go. There you go. Okay. Let's see what I did. I saw that I had an x on both sides. I divided out an x. I got 3x equals 4. Divided through by 3, I got 4/3. And you know what? I learned my lesson on the last one. So I did check. Let's see if 4/3 works. 4/3 squared is 16/9. 16/9 times 3. Let's write that out here. That's 3 times 16/9. Does that equal 4 times 4/3? Well, that's going to be 16/3. And, of course, 3/9 is a third. So, yes, 16/3 equals 16/3. Yep, so 4/3 is definitely an answer. But it started as a what? Squared, which, remember, squares or quadratics have up to how many possible solutions? 2. Where in the world would I even consider a second solution? Well, not the way I did it. I found one of the possible two. What did I do that was a big, big no-no? X disappeared. I divided both sides by a variable, and I lost it from both sides of the equation. And I remember something in all caps and bold right here. It says, when do you do that? Never, never, never do that. Okay. And I was very happy walking around. Many people did not follow my lead. They actually said, oh, I got a square term and an x term. That's when I get everything on one side. And I set it equal to 0. And when it's equal to 0, the first rule of factoring is to look for a common factor, which is x. And that gives me 3x minus 4. And now the zero product property says either x equals 0 or 3x minus 4 equals 0, which means x equals 0 or x equals 4/3. And indeed, I still get the 4/3, but I also pick up systematically my other solution of 0, which does work. Now, if you had given any thought to the equation in the beginning, you might have been able to pick out 0 just by looking at it. 0 equals 0. But this is a systematic way to make it fall right off the bone, right there. So, do not divide out variable information. If you lose it from both sides of the equation, you lose possible solutions. Okay, I think we got time for one more. E, F, G, and H. Which one looks uglier? H. Let's do H together. If we can do H together, we could do all the others together. All right. So, solve. There you go. Solve. Just to solve. And what's the degree on our x? The largest exponent is a 4. That means we can have up to 4 solutions. Do I divide everything through by an x and get rid of it? No. In fact, I already know that what's one of the solutions. Because I can divide through by an x, 0 should work. So 0 plus 0 minus 0 equals 0. But there could be 3 others. So let's go ahead and get everything on one side. Set it equal to 0. 3x to the 4th plus 6x cubed minus 27x squared minus 54x. And now it equals 0. Don't forget to keep it equal to 0. We wrote it in descending order as well. It was already in descending order. Next step, common factor. 3x. Very good. Leave the 3 there. Don't divide through. Just leave it there. We get an x cubed plus 2x squared minus 9x minus 18. Still equal to 0. So there you go. You have it partially factored. 3x equals 0 and x is 0. So we still have that 0 solution, but this cubic, you can have 3 more solutions. So got to try and factor it because I don't have the cubic formula memorized, nor do I have enough skin on my body to have it tattooed because it's very large, the cubic formula. So how can we factor that? We have grouping. Very good. We have 4 terms. So factor by grouping. So parentheses around the first 2, and here's where you have to be cautious, right? You have a negative right there. So put the negative inside and squeeze a little plus sign in there. Otherwise, you'll lose a point. Okay, so now the 3x hangs out there. This is where I put the beefy brackets. In the first group, we'll pull out an x squared, and we're left with x plus 2. And in the next set, we'll factor out a negative 9, and we're left with x plus 2. Close beefy brackets, still equal to 0. Still equal to 0. Okay, so now inside the brackets, we have the common factor of x plus 2. So we have a 3x, and we can drop the brackets, because we're going to factor out an x plus 2. And what other factor does that leave then? Yeah, in the first term in the brackets, we have an x squared that's left. And in the second term in the brackets, we're left with a minus 9. And it's still equal to 0. Now, from here, you could set each factor equal to 0. X squared minus 9, you could easily separate the variables and extract the square roots. Or you can continue on, because x squared minus 9 is a special product, isn't it? It is a difference of 2 perfect squares. So it will factor into the product of 2, don't make me say what you get, conjugates. Good. So 3x, x plus 2, and then x plus 3 times x minus 3, still equal to 0. Now we have its prime factorization into its linear factors. Okay? And you have how many variable factors? 4. The one that students tend to overlook, believe it or not, is the x, because it doesn't have the parentheses x minus 0. But if you set everything equal to 0, you'll get x equals 0, or what would be the next root of the factor x plus 2? -2, -3, +3. So I'm okay if you go straight from the factor to the solutions. Just be careful, don't list it as 0, +2, +3, -3. It's the x values that give you 0. So if you need to set them equal to 0, so you algebraically bring it across the equal sign and change the sign, do that. You don't want to just trip at the very end. And there's your 4 solutions. Okay, any questions on that? If you can do that problem, you can do all the rest of them. It says verify 4H on the graphing calculator. I'll just mention how you would do that. We would get everything on one side and set it equal to 0. We would graph this in y1, we would graph that in y2, and you're not going to see the graph of y2 because it's the x-intercept, but you would then count how many times it crosses, and there's a way to find them. So we're going to skip that for now. Okay, so tomorrow, come to class with 1.3 notes already downloaded into your iPad. We'll probably do a super short warm-up. No quiz tomorrow. We'll jump right into 1.3, kind of picking and choosing. And then we'll talk about the test tomorrow at the end of class. The worksheet for this section is due tomorrow. Hard copy, handwritten, turned in. Okay? I'll be here tomorrow at 7 a.m. if you have any questions. All right. Awesome.